A and B compete in a racket match consisting of at most 3 sets. Each set is won by either player A and B, and the match is won by the first person to win 2 sets. Right? And player A has a probability of 2/3 of winning each of the first 2 sets, and if the set goes into the third set, player A has a probability of P winning this set. Alright, let's look at part 1. With the aid of a tree diagram, we find in terms of P the probability that player A will win the match. So let's look at the first part. Okay, maybe what we can do, we let W. Let's look at this from the point of view of player A. Let W be the event where that player A wins the match. Wins a set, sorry, not wins a match, alright? So wins a set. You win 1 set, you must win 2 sets in order to win the match or to win the game, alright? The match is won by the first person to win 2 sets. So what we can do is put W, and maybe we don't put loose, I'll just put W prime, right? So with that, player A has a probability of 2/3 of winning each of the first 2 sets, right? So let's go to the second game, and again for player A, the probability of winning is 2/3, and the probability of losing is 1/3. Right, so because the question tell me to draw a Venn diagram, a tree diagram, I will draw a tree diagram as instructed. Right, and if the match goes into the third set, right, then player A has a probability of winning this set. So what do we define? We think carefully. What does it mean by going to a third set? It means that nobody has won 2 times. All right. So what the situation is probably that A has won 1 time, B has won 1 time, right? So could be something like, if you think about it here, there's not going to be any more third set because A has won 2 times. Here as well, there's not going to be any more third set because A has lost 2 times. So we are only looking at these 2, where A and B each have won once or twice. Once, okay? Right, so here the probability of A winning would be P. Losing will be 1 minus P. P, 1 minus P. Alright, so with that, how do we deduce the range of find the probability that A will win the match in terms of P? So what does it mean? Alright, so if you think about it, what are situations where A will win? Alright, so this would be the first one, probably. This would be one of those. Alright, that A has win. And second time would be this, alright, where A has also won 2 sets, right? Third time would be also this scenario, 1, 2, 3, right? 1, 2, 3, and 1, 2, right? The other scenarios, A is not going to win. So very quickly you can see that the probability of A winning the game in terms of P is just like the probability of WW plus the probability of win, lose, win, plus the probability of lose, win, win. Alright, and this would just be, as you can see, we calculate this is 2/3 multiplied with 2/3 plus 2/3 multiplied with 1/3 multiplied with P plus 1/3 multiplied with 2/3 multiplied with P, and the final answer comes out to be 4/9 P plus 1. Right, this is for the answer part 1. How about part 2? Right, so we want to deduce the range of values of the probability that A wins the game. Alright, what do we mean by deducing? So one thing that will help us is with a range of values. It means that first, if we look at P has to be between 0 and 1, right? This is what we're going to start with. Right, this is the thing that is very obvious, but sometimes we don't realize that actually this itself determines the range of values. So if given this, right, if we know this, right, and we know that the probability that A wins is going to be 4/9 P plus 1. So what's the range here? What's the range here? Right, so let's find out. Right, so if p plus 1, p is between 0 and 1, then p plus 1 is going to be between 2 and 1. Alright, and if you multiply by 4 over 9 on both sides, right, so I'm just basically engineering myself towards the function expression in which a is going to win the game. 2 multiplied by 4 over 9, this is 1 multiplied by 4 over 9, so it's just 4 over 9, and you can see that it's 4 over 9, and on the right hand side will just be 8 over 9. And what is this? This is just the probability that A wins the game, right? Wins the game, okay? Because it is given to us from part 1. We have found it in part 1, okay? And this is done for part 2. Part 3, alright, show that the value of P in order for the match to be fair is 1 over 8. So what do you mean by fair? Fair meaning it means that the chances of each person winning is equal. So it also means that the probability of A winning and B winning is each equals to half. And what's the probability that A is going to half? So half means what? It means that we also know from part 1 that the probability of A winning is equals to 4 over 9 P plus 1. Okay, let me just make it clearer that A wins equals to half. Okay, this means for the game to be fair. For the game to be fair, meaning that the chances of both sides winning are the same, right? This is what they mean, okay? But we also know from part 1, the probability that A wins is equals to 4 over 9 P plus 1, correct? So with that, right, we want to show that P is equals to 1. That's all we do. 4 over 9 P plus 1, we equate this to 1 over 2. Alright, simplifying this and solve, right, you can just get P plus 1 will be equals to over 2 divided by 4, 9 times 9 over 4, so it's just 9 over 8. Yeah, so P is just equals to 1 over 8, and that's all. We are done with part 3. Alright, and okay, now let's look at the fourth question. Now, given that player A wins the match, find in terms of P the probability that he won the second set. Alright, so we are looking at probability that A wins the second set given that he wins the match. Alright, what is this? This is just the same. You can also say this is the same as probability A winning second set combined intersection of the probability that A wins the match over the probability that A wins the match. Alright, and what's the probability that A wins the second set and he wins the match? So if we look at the portion here, let me use green. A winning the second set given A. Okay, so this is probably the one, right? He won the second set and he won the game, right? And probably the next one would be here. He won the second set and he won the game, right? So it's over here. So that means we are just looking at the probability of win-win and the probability of win or lose win-win, right? So that would be in the black portion. This is the probability of win-win plus the probability of lose win-win. Oh, sorry, not lose. I misused win prime. Okay, win prime. Right? You can use lose. You can use it or represent it in any way that you're comfortable with. All right, and as long as your answer is correct, and the probability that A win would be what we have found just now. It's just like that, correct? And the top portion would just be 2 over 3 square plus 1/3. 2/3. Just by looking at your tree diagram, you should get your answer, right? And just simplify this, you're going to get 2 plus P over 2 plus 2P, and that's all for question 3.